Hey everyone, welcome again. So this is the third video of our Spark interview series. In the first two videos, what we have covered? We have covered about general questions, we have covered about joins and partitioning and bucketing. And we have covered all these joins, partitioning, bucketing in a lot of details. So when I say a lot of details, it means if you just watch these videos, there should be no questions coming in the interview outside this. That's what I'm thinking. In this particular video, we will be talking about Spark performance tuning question and answers. So let's go through it. In this video, we will be having almost 30 questions, right? 30 question in the and 30th question will be about performance tuning in Spark 3.0 and after that, right? So since Spark version 3.0, what are the additional feature come in the performance tuning? We will be covering it. So let's start the video. um, See, when we talk about performance tuning is a vast topic. What we have covered in previous two videos is somewhere part of performance tuning as well, but in this video we will be specifically talking about performance tuning in terms of how we can improve it, right? Direct questions in terms of performance tuning. So let's start with it. So the first question can be, what are the common performance bottlenecks in Spark? So when we talk about bottlenecks, can be caused by various factors, including input-output operations such as reading and writing data to disk or network, data shuffles where data is transferred between the nodes, um, garbage collection where the GVM stops the application to reclaim memory, skewed data distribution where some partitions have more data than others. Then the last one, and it's not the last one, there are others, but the major one is underutilized resources such as CPU, memory, and network bandwidth. So this is these are the common performance bottleneck in Spark and even in any other parallel processing framework. So how do you optimize data shuffle in Spark? So we have covered data shuffling in a lot of details in the previous join video, but let's see here. Data shuffles can be optimized in the following ways. You can do repartitioning to balance the size of partitions. You can use broadcast variables for the small lookup tables so that data is not shuffled. Tuning the serialization and compression settings for the shuffle data. Enabled pipeline shuffle where the multiple stages can operate in parallel on different nodes. So this all we have covered in joins video, right? Joins video we have covered this, and if you want to know detail about it, go to check the join video. The third question is, what is the significance of spark.executor.memory and spark.driver.memory setting? There is a question afterwards in this performance tuning video in which I will be touching upon all the important properties of the cluster which may impact the performance. So let's see these two properties, Spark executor memory and Spark driver memory. So when we talk about a Spark executor memory and driver memory setting, this determines the amount of memory available to each executor and driver respectively. Increasing the memory setting can help avoid out of memory error exception, but it also reduces the number of executors that run on a single load. The appropriate value depends on the amount of memory available on the cluster nodes and the memory requirement of the Spark application. Okay. The fourth question is, how do you tune Spark jobs to minimize garbage collection pauses? To minimize garbage collection pauses, you can increase the Spark executor memory, spark.executor.memory setting to allow more memory to be used before GC is triggered, right? And decrease the frequency of GC by tuning spark.executor.extra Java option setting with the options such as -XX plus use G1 GC or -XX plus use conf mark strip GC. Monitor GC metrics and adjust the GC setting based on the observed behavior. So what happened in GC or garbage collection? So when GC is taking place, Spark stops the processing for some time, collect the garbage and once the garbage is collected, then it start working on the on the processing. To improve this, you can either decrease the garbage collection frequency or increase the executor memory in very simple way, right? Can you explain the role of a Spark executor and how they impact performance? So, Spark executor are responsible for the execution of the task assigned to them by the driver. The number and configuration of executor can impact performance by affecting the amount of available resources for processing tasks and the overhead of the task coordination. To optimize performance, you should configure the appropriate number of executor and memory setting based on the resource available in the cluster and the requirement of Spark application. So we all know executors are the worker nodes, and how much memory, how much processing power has been assigned to these workers will impact the performance in very simple way. What is the purpose of Spark broadcast variable and how do they impact performance? Again, we have covered this question in the join video, but let's see quickly. Broadcast variable are read-only variable that are cached on each node in the Spark cluster rather than being transferred with the each task. They can be used to efficiently share large lookup tables or other data structure across tasks. Using broadcast variable can improve performance by reducing network overhead and avoiding the need to serialize and deserialize the data with each task. See, broadcast variable and broadcast join have been covered in join video. If you need more detail, please go through it. We will be moving to the next question. How do you monitor and troubleshoot performance issue in Spark cluster? Very important question. So let's highlight this. How do you monitor and troubleshoot the Spark performance in the Spark cluster? To monitor and troubleshoot performance issues in Spark cluster, you can use Spark Web UI to monitor the progress of application and identify flow and fail tasks. We will be talking about this point in a lot of detail in the next few questions. Use Spark log output to identify error and performance issues. You can use Spark metric system to monitor the usage of resources such as CPU, memory, and network. Profile the Spark application to understand the performance characteristics of the code, such as hotspot and memory leaks. We will be covering hotspot, might be in the later section, not in this video, might be in other videos. Monitor the performance of the underlying cluster, including usage of resources such as CPU, memory, and the network, and identify any bottleneck that may impact the Spark performance. Experiment with different configurations such as the number of executor, memory setting, GC option to find the optimal configuration for application. This point is again very important. So you cannot find the optimal configuration of the cluster or the application in a single go. You need to keep trying. And there is a thumb rule which we will be covering later on the number of executor, memory setting, etc. Right? So, eighth question is, can you discuss the trade-off between using high number of small partition and low number of large partition in Spark? Good question. Lot of time this question has been asked. So let's see. Okay, the number and the size of partition in Spark can impact performance. High number of small partition can improve parallelism because number of partition is equal to number of tasks. So if there are high number of partitions, a small partition, there will be more parallelism, but can also increase the overhead of task coordination. More the task are, more the coordination. On the other hand, low number of large partition can reduce the overhead, but limit parallelism. The appropriate number and size of the partition depend on the specific requirements of application and the resources available in the cluster. In general, you should aim to balance the trade-off between parallelism and overhead of the to maximum performance. How do you configure Spark to make effective use of available memory? Great question. To configure Spark to make effective use of available memory, you can set spark.executor.memory setting to a value that is appropriate for the resources available in the cluster. tune the Spark configuration to control the size of varied data structures such as the size of broadcast variable and the storage level of RDDs. We will be talking about the storage level in next few questions. Monitor the memory usage of Spark application and adjust the configuration needed to ensure the application runs within the available memory. I think this particular point and this point is an interrelated. So it means you need to adjust the configuration, but to adjust it, you need to hit and try multiple times. Can you explain the difference between narrow and wide transformation? And the further question will be which is more performant, narrow or wide transformation? Let's see the definition first, and then we will see the performance of narrow and wide transformation. Narrow transformation in Spark is a transformation that does not require data shuffling between nodes, such as map and filter operation. Narrow transformation can be executed in a pipeline fashion, which can improve performance by reducing the overhead of task coordination. A wide transformation in a Spark is a transformation that requires data shuffling between nodes, such as group by key, reduce by key operation, and even join operations. Wide transformation can be more expensive than narrow transformation, as they require data shuffling and can result in increased network and disk input output, right? To optimize performance, it is important to minimize the number of wide transformation in Spark application, right? Can you explain the role of Spark cache in performance tuning? So Spark cache is a feature that allows you to persist an RDD or data frame in memory so that it can be reused across multiple stages. Multiple stages in a Spark application. Caching can significantly improve performance by reducing the overhead of recomputation of immediate result and reducing the amount of data that needs to be shuffled between the stages. To efficiently use Spark cache, what we should do? We should be caching only the RDDs and data frame that are frequently used in multiple stages of your application. So you should not be caching everything because obviously you have limited memory, right? Monitor the cache usage and eviction to ensure that cache do not run out of the memory. Consider using different storage levels such as memory only, memory and disk depending on the requirement of application. So this is important. If you tell this part, it might look that okay, you know a lot of stuff, right? So memory only, memory and disk only. So these are few options when we talk about, and this is related to persist, right? What the next thing? Okay, can you discuss the role of Spark Shuffle in performance tuning? So shuffling means data transfer across network. So it means more the shuffling is, less the performance. So it means if you prevent shuffling, you will increase the performance. And let's read the answer. Spark Shuffle is a mechanism that redistributes data between nodes in a cluster. Shuffling is necessary for certain operations such as group by key and reduce by key that require data to be grouped or aggregated across nodes. Shuffling can be performance bottleneck in Spark, and it requires network and disk input output, right? To optimize performance of a Spark Shuffle, what you can do? You can minimize the number of shuffle operation and operation. Like this means the wide transformation, right? You can reduce the wide transformation. Configure the size of shuffle buffer to control the amount of data that is kept in memory before being written to the disk. Monitor the shuffle performance and identify any shuffle bottlenecks such as slow disk input output or network congestion. Can you explain the role of Spark serialization and performance tuning? So what is Spark serialization first of all? Spark serialization is a process of converting data structure in Spark to a binary format that can be transmitted over the network or stored on the disk, right? So you have some data, you want to send it across the network or you want to store it on a disk, then you will go for serialization. The efficiency of serialization can have a significant impact on the performance of Spark application as it affects the amount of data that needs to be transmitted between nodes and the speed of data serialization and deserialization. To optimize it, what you can do? You can choose efficient serialization library such as Cryo and Java or Java serializer depending on the requirement of your application. Configure the Spark serialization library to use compact binary format that reduces the size of the serialized data. Minimize the amount of data that needs to be serialized by caching intermediate result in memory or disk where possible, right? So important bit is cryo. People do ask it about a lot. What is cryo serializer? So cryo serializer is a serializer which will compress the data. It's more efficient when we use it with Spark, right? So can you explain how would you determine, how would you optimize the performance of SQL query, Spark SQL query? Um, it's not only with SQL query, it should be applicable in any SQL query. So I mean to say it's not only with Spark SQL, it will be applicable. These points should be applicable with any SQL query, right? Make sure data is being queried properly, partition and optimized for query performance. Use indexes or partition pruning to reduce the amount of data that needs to be scanned. Use the Spark SQL Catalyst Optimizer. Catalyst Optimizer is a question which people can ask. So I'll highlight it and we will be covering it later. To optimize the query plan and consider using explain plan to understand optimization applied by the optimizer. Broadcast join, you can use Spark data compression to reduce the amount of data that needs to be transmitted over the network. Okay, how do you troubleshoot a slow Spark job? Very important question. So first of all, first thing is to identify this slow Spark job, and once it has been identified, you can use Spark Web UI to monitor the performance of individual stages and tasks. So this one, individual stages and tasks, you can monitor in Spark UI and identify any stage or task that is running slowly. Use Spark logs to identify the errors, any errors or exception that may be affecting the performance of the job. Monitor the performance of underlying cluster using CPU, memory, network, etc. Consider using profiling tools such as JStack or Flame Graph, or different tools are available in the market to understand the performance of individual tasks or stages in more detail. If the issue is related to data processing or storage, consider optimizing the data storage format using data compression or using more efficient data processing algorithm, right? Uh, how Spark works with large data sets. So we have covered it in last video as well, but let's see here. Spark was designed to handle large data set by processing data in parallel across multiple nodes in the cluster. Spark uses a distributed data storage model where data is divided into partition that can be processed in parallel across nodes. To work with large data set in Spark, you can use Spark data partitioning feature to divide the data into smaller partitions that can be processed in parallel. Consider using Spark data storage formats such as Parquet, Avro, ORC, which are optimized for large data set and provide efficient compression and serialization. You can Spark use lazy evaluation model to delay the evaluation of the transformation until they are actually needed, reducing the amount of data needs to be processed at any given time. So once you hit the action, then only this transformation will actually be executed, right? Consider using Spark distributed memory cache, which allows you to persist immediate result in memory across multiple stages of the application. What is the role of Spark execution mode in performance tuning? Oh, that's great. So Spark runs on two mode or three mode: client mode, local mode. Local mode or client mode should be same, and cluster mode. In client mode, Spark's on, okay, local mode is single mode actually. So there are three modes. One is client mode, and sorry, client mode as well here, right? So let's talk about local mode. In local mode, Spark runs on a single node using single JVM process, where in cluster mode, Spark runs on the cluster of nodes, while each node running its own JVM process. The choice of execution mode can have the significant performance on the Spark application. In general, cluster mode is more suitable for large data sets and provide better performance, as it allows Sparks to process data in parallel across multiple nodes in the cluster. Local mode is more suitable when a smaller data set and a smaller data set and the development and testing scenarios where overhead of managing cluster is not necessary. Now talking about the client mode is used when you want to see when there's large data set you want to process and you want to see the result on the client machine. For example, when you are doing interactive query execution, right? When it talks to the so who which one is best performant, obviously cluster mode, because the jobs are running on the distributed cluster, right? um, how can Spark shuffle operation impact performance? We have explained it to you. Spark shuffling is the process of redistributing of data across the Spark cluster. And it occurs when data needs to be rearranged, for example, using group by join and repartitioning, right? While shuffling is necessary, but it can be avoided using alternative operations, or you can even reduce the amount of data to be shuffled. Shuffle is expensive for network input, output, and computation, and can cause slowdowns if not managed properly. What you can do for improve the performance of shuffle operation? You can use data partitioning, you can use broadcast join, you can use data compression, you can monitor the performance, right? And you can adjust the parameters related to the shuffle. How does Spark handle skew data in cluster? We have covered this question. Data skew occurs when a small number of partitions contain significantly more data than other partitions. So this definition I really like about skew data. Data skew can impact the performance of a Spark application. It is cause the same some nodes of the cluster to heavily loaded than the other RIDL. Sorry. Use Spark data partitioning feature to ensure data is partitioned in a way which balances the load across cluster nodes. Consider using data sampling. Consider using Spark broadcast join to reduce the amount of data to be shuffled across nodes. There are multiple ways. We have covered it in join video. What are some of the common performance bottlenecks? We have covered it. Let's see. So performance bottlenecks can be slow data ingestion. If the data ingestion rate is slow, it can limit the overall performance of the application. Shuffle operation, resource contention. It means if a cluster does not have enough resources, such as CPU, it will impact the performance. Serialization, deserialization. So what serialization and deserialization do? They if serialization and deserialization of large amount of data can be slow and performance bottleneck. So we should be using a cryo serializer or other serializer to do this. Unoptimized data storage, so it means if you are using data formats such as plain text or CSV, that can limit the performance. To avoid these performance bottlenecks, you need to use proper Avro or Parquet or ORC formats. How does caching improves impact the performance? So we have covered it. Let's quickly read it. Caching is in Spark have a significant impact on performance, as it allows intermediate result to be stored in memory, reducing the time required to compute these results in future stage application. So what it means, if you have some result, if you want to use it again, you will cache it. So you do not need to recompute it, right? So caching is especially beneficial for Spark application that requires frequent access to the same intermediate result, such as iterative algorithms. However, it is important to use caching judiciously, as caching too much data in memory can lead to the memory process and slow down the application. It is also important to monitor the cache usage and clear the cache when it's no longer needed, to avoid using cache to simple to avoid out of memory error, right? Can we discuss data serialization on Spark performance? This is interesting. Let's see. Data serialization refers to the process of converting data structures to compact binary format that can be transmitted over network or stored in a disk. The choice of data serializer format can have a significant impact on Spark performance. So Spark supports several data serialization formats such as Java, Cryo, Avro. Each format has its own trade-off in terms of performance, efficiency, and compatibility. So to optimize, what you can do, you can choose the appropriate data serialization format based on the requirement, including the size of the data, frequency of serialization, deserialization, and computational resource available in the cluster. Use data compression to reduce the size of the data. Use partitioning. And if we conclude, data serialization is an important aspect of performance tuning. So you need to consider carefully and based on the right choice of data, choice of data serialization format and optimization technique used to achieve the best performance. Okay, now this is what I was talking about. What are some of the cluster parameters you can tune to tune the performance, right? So the first is Spark driver memory. What it will do? Spark.driver.memory sets the amount of memory that is allocated to Spark driver. Increasing this value can improve the performance of the application that required a lot of memory for processing. Spark executor memory, it will allocate the memory to each executor. Increasing this value again can improve the performance if more memory is required for the processing. Executor cores, Spark executor cores gives the number of cores to each executor, and increasing it might increase the performance as well or end the parallel processing. Executor instances. So one is executor core and other is Spark executor instances. This sets the number of Spark executor data created for each application. So increasing this can improve the value performance by allowing them to process data in parallel across multiple nodes. Spark task CPUs, it will number of cores that each Spark task uses. Uh, Spark default parallelism. This will set the number of partition data used by Spark to process data. Spark memory fraction set the fraction of memory that is reserved for Spark internal memory management, such as caching data and memory. Decreasing this value can improve the performance of application by allowing them to use more memory processing, but this is not always true. You need to be very careful when to set this parameter. Um, there are others as well. For example, Spark RDD compress, the level of compression for RDD is stored in memory. Spark network timeout set the maximum times in millisecond that a task can wait for the data from the network connection. Spark shuffle compress, this is what we were talking about to compress the shuffle data, right? Spark memory storage fraction. Okay, so Spark memory fraction is one, Spark memory storage fraction. Set the fraction of memory that is reserved for Spark internal storage, such as caching the data in the memory. Okay, so these are just few examples. There can be another example, but these are, especially these are the main one. Let's bold them all. So these are all the main one. Please go through them, and these question might have asked multiple times in the interviews, right? Um, so now when we talk about Spark performance, where should we look for the parameters? Where should we look for the configuration? And what should we look for? So the most important when using Spark UI to monitor performance of Spark application, there are several parameters to look for. So Spark UI is the right place to look for performance bottlenecks. What we should look there? Five or six things are very important. One is executor details. It displays the number of cores, memory, and executor ID of each executor in the cluster. This can help to identify any imbalance in the distribution resources across executors. Task matrix displays the number of tasks that were computed, failed, and skipped, as well as total number of runtime and average task time. So this is very important. It will show you the number of tasks which are completed, failed, and at the same time it will show you what is the time taken to complete the task. Then we go for stage matrix. This will show you the number of stages that was complete, skipped, and at the same time will tell you the total runtime and average stage runtime. Then we go for RDD storage, displays the size and amount of RDD data stored on the memory disk. Executor logs, SQL tab. In the SQL tab, it displays the SQL query executed by the application, include the execution time, number of rows returned, any optimization performed with the Spark. Event timeline, again a very important bit, displays the timeline of event occurred in the execution of the application. So to monitor performance, you will go for Spark UI. In Spark UI, you will look for these particular details, right? Um, so what is serialization? We have covered is serialization. So there is n number of serialization, Java serialization, cryo serialization, and last one is protobuf. Let's see what protobuf is. Protobuf serialization is a high performance serialization library that is designed to for efficient serialization, deserialization of data. It provides compact binary representation of data, which is ideal for network transmission, but requires a schema to be defined, the data being. So this is important. For protobuf is great serialization, but it requires the schema to be defined. Last bit, identify the bottleneck using Spark UI. So Spark UI provides comprehensive view of the performance of a Spark application, which can be useful for identifying bottlenecks and performance issue. So for example, we can monitor the executor details, we can monitor task metrics, we can monitor stage metrics, we can monitor RDD storage, executor logs, SQL queries, event timeline. So all these parameters we can watch, right? Let's see the most important bit. What is project function and what is catalyst optimizer? So Project Tungsten and Catalyst Optimizer are two performance enhancing feature in Apache Spark. What is Project Tungsten? It is a performance optimization effort in Spark that aims to improve the performance and efficiency of Spark by reducing the overhead of garbage collection and serialization, improving memory management, reducing CPU overhead. What Project Tungsten uses? It uses techniques such as off-heap memory management, code generation, specialized data structure for performance, improved performance. What is Catalyst Optimizer? Catalyst Optimizer is a query optimization framework designed to optimize the execution of SQL and data frame queries. It performs various transformation on the query plan to improve performance, such as push down predicates, elimination of unnecessary results, optimization data layout. Um, so when these two things mix together or work together, they will improve the performance. Now, I want to jump to Catalyzed Optimizer in other detail because this question asks a lot. So what is Catalyzed Optimizer? We know Catalyst Optimizer is a query optimization framework for Apache Spark, playing key role in optimizing the execution of Spark SQL and data frame. It is a key component for SQL, Spark SQL engine, and responsible for transformation of query into the optimized plan that can be executed efficiently by Spark. Okay, so what are the key features and benefit of Spark Catalyst Optimizer? So first is it has rule-based optimization, it has cost-based optimization as well, it has expression optimization, it will generate the code. So Catalyst Optimizer also support code generation, which allows Spark to generate optimized code for the specific operation at runtime. It has Planner API. So what Planner API will do? It will allow developers to add their own optimization technique. It will improve the performance, of the SQL and data frame by reducing the amount of the computation required and the minimizing data movement. So in summary, Catalyst Optimizer is critical component of Spark SQL engine and plays a key role in optimizing the SQL execution of Spark SQL. How to reduce shuffling? Shuffling is an expensive operation. So how to reduce it? So you can reduce shuffling by minimizing the data movement. Shuffling means data movement and how to minimize it. Shuffle operation can be expensive because they require large data movement across partition. To minimize the cost of shuffle operation, it is important to minimize the amount of data that needs to be shuffled. It means you can filter the data, you can do all the processing before you had to shuffle the data. This can be achieved by using operations such as filter aggregate that reduces the size of data before it's shuffled. Use broadcasting. So if you have a data set that is small enough to fit in the memory, broadcast it so that it do not need to be shuffled again and again, right? You can use optimized serialization, you can use repartition, you can configure the number of partition properly. So these all are methods which will help you to reduce the shuffle operation. Okay, if somebody asks you what are the most expensive most expensive actions, so any action, so obviously there's no as such expensive action, but there are expensive what we call transformations. So any wide transformation such as group by key, reduce by key, go group, join, flat map, so these transformation which causes shuffling are expensive ones. Simple. Actions with large number of tasks are expensive. So actions with large number of tasks such as reduce and aggregate can be expensive because they require significant amount of data, amount of coordination between tasks. Action with high serialization overheads. For example, the serialization which needs data to be collected at driver node, high amount of data can be expensive. So these are some of the questions. The last question is which one is the best API to choose from, right? So choosing the best API depends on the use case. So If so there can be multiple APIs, RDDs, data frames, data sets, Spark SQL, right? So RDDs are fundamental data structure in Spark and are used for processing large immutable data sets. RDD are suitable for the use case when data needs to be processed in parallel and where data can be divided in partition. One more point which is missing here is when you need more control, when you can program it, when you need to define your own logic. Data frames are an abstraction over RDD that are used for processing structured data. Data frame are suitable for data which process parallel and data has schema. So if your data has schema, go for data frame. The cool part about data frame, dataset, and Spark SQL is they have this catalyst optimizer and optimization, all the optimization behind the scene. So RDD is like the basic abstraction, which might not have all the performance tuning what Spark has did for us, right? Datasets are similar to dataset but are strongly typed and allow more type safe processing. So if you want to go for coding type processing, type safe processing, you will go for this. There's Spark SQL. Spark SQL will be used uh, if you know the Spark coding, sorry, SQL coding, you can go for Spark SQL. The cool part about Spark SQL is it has tungsten, it has catalyst. So when you write select star from table name where name is equal to Nilendra. So what it will do, it might do partition pruning, it might do all the cost speed optimization and different stuff behind the scene. So if you ask me which one is the best API, if you have a schema, if you have choice to use it, I'll 100% go for Spark SQL. Okay, and then there's GraphX, which I haven't used. So GraphX is suitable for when data is represented as graph, and graph processing required. The last thing is very important. What is performance tuning methods available in Spark 3.0? And what are the different properties available, right? So Spark first is caching data in memory. So Spark SQL can cache tables using in-memory column format such as by calling spark.catalog.cache table, and then you can give the table name, or you can say dataframe.cache. Both are doing the same thing. So Spark SQL will scan only required columns and will automatically tune compression to minimize the garbage collection pressure, right? Which configuration you can set in Spark setconf and Spark session. You can set this one, the Spark SQL in memory column storage dot compressed. You'll set it to true. When this property has been set to true, Spark SQL will automatically select the compression codec for each uh, column based statistics. So this one is available from Spark 1, nothing new. I want to show you something which came into Spark 3.0. For example, this one, Spark SQL files min partition number. So this was default parallelism. The suggested, not guaranteed minimum number of split file partition if not set. The default value is Spark default parallelism. This configuration is effective when use file based sources such as Spark, JSON, and ORC. Okay, we can give join strategy hints in SQL queries. For example, there are different join strategies such as shuffle hash, merge join, broadcast join, replicate, right? Shuffle, replicate, NL. What you can do in Spark, you can give hint using this one. So you can, if you want to give hint, so you'll say dot hint, then you'll say broadcast. So it means what Spark will do, Spark will try to implement that hint if possible, right? You can use in data frames like this, or you can use in SQL like this. Select, then slash, then coalesce, repartition, rebalance, whatever you want to use. Most important bit which I want to cover is adaptive query execution. This is brand new feature in Spark 3.0. What adaptive query execution is, an optimization technique in Spark SQL that makes runtime statistics makes use of runtime statistics to choose the most efficient query execution plan. Okay, what happened is what adaptive means here is the execution plan. So before Spark 3.0, what is going on that there is one query plan which is selected and it will be executed throughout the query, right? What happened in Spark 3.2.0 is AQE has been enabled, so it means every time when query will run, it will adapt the execution plan based on the runtime statistics. So it means all the runtime statistics will be considered to choose the best efficient query plan. So it's not one time plan. Every time runtime statistics change, it will see those statistics and will try to improve the query execution plan. Spark SQL can turn on and off AQE by spark.sql adaptive.enabled. Okay, coalescing post shuffle partition, so this feature coalesces the post shuffle partition based on the map output statistics. So this again came in 3.0. So you can use spark.sql adaptive coalesce partition is equal to true. When true, Spark will coalesce the contiguous shuffle partition according to the target size. Then one more important bit here is um, this one, Spark SQL adaptive advisory partitioning. The advisory size in bytes of the shuffle partition during the adaptive optimization, if it is enabled, it takes when the Spark coalesces small shuffle partition. One more feature is property name is Spark SQL adaptive auto broadcast threshold. So if it configures the maximum amount of size in the table that will be broadcasted to the worker nodes by a join. By setting this video value to -1, broadcast can be disabled. Sort merge join can be uh, converted short merge join to shuffle as join using this properties SQL Spark SQL adaptive max shuffle hash join local map threshold, right? Last one and the most important one, optimizing a skew join. So this is again adaptive query execution. So first of all, you need to it takes effects when Spark SQL adaptive.enable is true and Spark SQL adaptive skew join is true. These is these are the two important properties which is the game changer in AQE. So in this, you need to turn this property on, spark.sql.adaptive skew join enabled, right? This one true, and spark.sql.adaptive enabled is good true. And then you can tell, okay, spark.sql.adaptive skew join is skew partition threshold as well. Um, by default, it's 256 MB, and by this property, this one Spark SQL adaptive SQL join skewed partition threshold bytes. By this property, we can say a partition is considered as skewed if the data in the bytes is larger than the thresholds. For example, you will say that okay, you know that okay, your data, the maximum partition size can be 100 MB, but if you see the partition size has been increased to 200 MB, 300 MB, it means the data in that partition has been skewed. So you can by this property you will identify the skewed partition, right? I think these are the most important questions which can be asked. In the next video we will be covering cluster configurations as well. So next video will be about how to define and design the cluster and how to optimize the cluster as well. So this is all from the performance tuning point of view. If I miss something, please do comment. Please subscribe the channel. Please share it with your friends. It will help everyone who are impacted from layoffs, right? And who is planning to prepare themselves for the interview. So thanks again for watching this video. I really appreciate your time. Thanks.